Hello everyone, my name is Grecia and I am the program manager for the digital community at Women Who Code. Today, Sahaja Yerramsetti, senior data engineer at Capital One, will present us the talk, Dare to Write Functional Code. Welcome Sahaja and thank you so much for being here today.
Hey everyone, I'm really excited to start talking about functional coding today. So the agenda for today is first I'll be going over what functional programming is and a bit of the core concepts that are behind it and what define it. Then I'll be walking through a use case of how I implemented functional coding at Capital One. Then I'm going to demo the code that I created. And I wanted to give a compare and contrast between a block of code and how it looks in a loose, not as strict language like Python versus a more strictly typed language that's more functional programming friendly like Scala. So I rewrote the same code in Scala. I'll also be demoing that. Then I'll be comparing and contrasting the two, and we can talk about takeaways and resources if you're interested in learning a little bit more about functional programming. So I'm going to start off with a quote. This quote says, the main goal of functional programming is to wrap your logic into self-contained functions to kill as many dependencies as you can. So the point of functional programming as a paradigm is to create more easily testable code because modular functions give you an advantage. And the basic core concepts of functional programming are very heavily math-based. And the point of it is to make each function in your program as independent as possible, meaning no function is dependent on another function or things declared outside of the scope of that function. And a really great advantage of functional programming to further add to that is that by creating your programs and code that way, your functions become more modular, more easy to test, and they become reusable, which means that when you write a block of code, you are writing the function as good as possible so that it is not restricted to your program. Anyone should be able to use it. And I'll go deeper into this as I go through more slides, and hopefully it makes more sense. So the core concepts of functional programming are these 3 bullet points that I've listed here. Immutable data, which means that the state of the data cannot be altered. And then the second concept is that code is centered around functions, which are ideally pure. And I'll go into code examples to help you better understand what are pure functions. And FP is more outcome focused than process focused. So rather than thinking of a location and thinking, how do I get there, which is what imperative programming does, functional programming is, okay, I see my outcome, let's work backwards. This is what my outcome is, and I need to get there without thinking about the how. And maybe a better way to explain it would be to think of an analogy. So a good analogy for comparing what FP works like in the real world would be kind of like a buffet. The goal of a buffet is to feed a lot of people with a lot of different options. So each dish is cooked independently and they're all put out for people to eat. Just because one dish is missing doesn't necessarily mean that your buffet is going to have issues or something is going to go wrong, right? All it means is that one dish is missing, but people still get to have all of the other food and they still get to have a good lunch. So now I'll go into some more details about each of the core concepts I explained. Let's start with immutable data. So in certain languages, there's immutable data structures. And I'm sure if you've coded in Java before or any strictly typed language, you know of this. It means when you initialize an object with a value, every time you use that value, a copy of that object is created, and that copy is the one that's mutated or changed. There is no direct transformation on the original structure. However, this isn't always enforced in all languages, and Python is an example of a language where it doesn't really have immutable data structures, and you can always reassign values. So here's some code examples of immutable data. So the first function is, it's called increment by 1. You're giving it an input of x, and you're reassigning x to x incremented by 1, and you're returning that. That is a bad example and code that you never want to see in, when your goal is to write functional code, you never want to see a function like this in it. The bottom left example is also increment by 1, but you're not actually reassigning the value of x at all. All you're doing is you're returning x plus 1. This is an example of a good functional program because you are not mutating any data here. You're just returning what the function was given. You're returning that plus 1. And then the bottom right example is the same thing, but here you're just assigning x plus 1 to a new value called y, and you're returning y. So both of these are good examples of how you're practicing and preserving the state of your data. So this is an example of Scala. It's the same function, increment by 1. I have a parameter, I'm passing it x, which is supposed to be an integer. My output will also be an integer, and I'm returning and reassigning the value of x as x plus 1. However, this in Scala, it's a bad example like the previous Python one I showed. And the neat thing about Scala is because it's so FP friendly, the compiler will catch this when you try to run your code, and it will say, hey, you can't reassign a value because you can't just fix what x is and mutate the state of x. It won't let you do that. These two are good examples of working proper functional code in Scala. And the top one is the same. They're both the same examples as the Python ones I showed. The first one, you're reassigning the value of x plus 1 to a new value called y. And the bottom one, you are just directly returning x incremented by 1. So for both of these functions, when you run increment by 1 with the integer 2, you'll be given the output of 3. So now let's go into pure versus impure functions. So I have an example of pure function on the left and impure on the right. And let's look at the key differences. The definition of a pure function can be narrowed down to like 3 points, I believe. The first point is you need to have an input and an output. So in the function on the left, you can see we have an input parameter of z, and we have a return statement, which means we also have something we are giving back or giving as an output. The function on the right does not have an input, and it does not have an output. There's no return value, and there's nothing that the function is taking in. The second point to what is a pure function is there are no external dependencies. The scope of your function is within your function. It does not rely on anything outside of the function in order to run. So we can see here that we don't use anything within this function that depends on something outside of it. However, for this function, the one on the right, we declare z outside of the function. And this becomes a problem because what if z suddenly is commented out in your line of code, or what if z doesn't exist, or z is never initialized? Then your function doesn't run because z does not exist. So that's an example of what an external dependency is. And the third most important point of a pure function is that it only interacts with the input it's given. So this ties into external dependencies where you could place this function in any code anywhere or in any program, and your output and the way it would work would always be the same. It would never change. Versus if you took just this part of the function, because technically that z equals to 0 is outside the scope of the function, if your z value is different in another program in another place, it wouldn't work the same. So that is kind of the what categorizes a pure function versus an impure function. So now we'll go over the Scala translation of that. So the top one, super succinct, short, easy to read and understand. You're defining a pure function, or the function is called pure function. It takes an input parameter, which is an integer, and it spits out that plus 10. You can use this line of code anywhere. This is, again, ties back to the reusability of functions within functional code. That's why functions are made to be so modular. And you could put this anywhere, any place, any program, and it would serve the same purpose and it would work exactly the same. Versus this bottom one actually doesn't compile because you've initialized z outside up here with 0, and then you're trying to reassign the value. So even if, I guess this function would work if you had y is equal to z plus 10, but it's still an example of an impure function that shouldn't be used because you have a side effect or an external dependency, because the scope of your function is not just your function. There's stuff outside of it that it relies on. So next, I'll be going over my use case. So my use case is that there's still vendors who use mainframe files. And one of the use cases that I was given was, as you know, Capital One is a fintech company. So one of the vendors we work with is called TSYS, and they process a lot of financial transactions, and we work with them. And the LOB that I work with, or LOB stands for the division of Capital One that I work in. It's commercial tech, and one of our products wanted to add a feature, and the feature was basically to process files given back to us from TSYS. So the use case was I had to develop code for a Lambda, which would be activated by dropping a file into an S3 bucket. And that file is a mainframe file, and I had to extract the body for it and parse the contents. So for an example of how a mainframe file looks, this is how it looks. It's 5 lines. The first 2 are headers. The middle is like called the body of the file, and the bottom 2 are trailers. And my task was to basically write a code, write a piece of serverless code that would give me all 5 of these lines as an output somehow. So before I show you what my code looks like now, I want to go over to how I approached this at the beginning. So I just had a simple function called retrieve parse file. I would pass it the event, which is the S3 trigger. And for every record in the list of event records, I would extract the bucket name, I would extract the object name, and then I would access the file contents by creating an S3 client. And I would return the body as well as the object name. So a lot of reasons this is not functional code is because, for one, there's no error handling. You don't see a try catch block. So if this fails, what happens? My code just doesn't run. There is no validation on any of the parameters. I don't check if bucket name exists or object name exists before actually calling to S3 to get the object, because why would I call if I don't have bucket and object name? It just doesn't make sense. I also don't check for the verification of data for any formatting. Like, I don't check if bucket name should be an integer or if object name should be a string, or I'm not doing any checks in that case. So now I'll show you how I translated that old block of code through IFP it X. I basically converted it into functional programming. So I'm gonna stop sharing, and then I'll share my entire screen again. And give me 1 second. Okay. So before I run the code and demo it, I actually want to walk through it so that it makes sense for what I did. So here I have an S3 event as a JSON file, and I am loading that as the event into my function of Lambda handler. So then in Lambda handler, I'm basically calling this function called getFileInfo, passing it the S3 event, and then I'm just printing it out. So we remember when I said functional programming is very outcome focused. So it will make more sense if I go over my code from the bottom up instead of from the top down. So if we start from file info, get file info, what this function is doing is it's checking to see if event exists. If it does, it's passing event to this next function. And then once this next function spits out an output, it's passing it to the next function below, and then it's doing the same thing again. So this concept in FP is called currying, and currying kind of works like dominoes. So if I want 4 functions to run and the output of each function to be given to the next one, I push the first domino over and my entire code runs in a sequence like that. So now let's go over what each of these functions does. So first I do a maybe check for the event. Does the event exist? If it exists, pass the event to get first record. So get first record takes the head of the event, so the first event, because assuming one file is dropped in at a time, there should always only be the first record that I care about, and that's how this transaction would work. So then if the first record is none, I return nothing, and instantly the program should clock out and just exit, which means my runtime is reduced and I am not running the whole program if my first event does not exist or my first record does not exist. So I added print statements along here. So when I demo the code, you can actually follow along and see this. But the output for this function is just return the first record. Then my next function is I get the bucket and object name because that's what I need to call the S3 bucket. So then in this one, I pass in the first record, which is the output of this, to this function. Now here I'm calling two other functions where I'm checking to see if the first record exists again, and then I am passing the result of the first record to get bucket name. And get bucket name extracts the JSON part of the bucket name. And if it doesn't exist, return nothing. If it does exist, just give me back the bucket name. Object name works the exact same way. Then what I do is I have another check for making sure they both exist. And if they do both exist, I return both of them packaged up together because I want them together to be able to call S3 with both of those parameters. And then the last one is I get the object. So get the object takes in one parameter, which is the bucket object name. Then I decompose the package details into bucket name and object name. Then I extract the bare bucket name and the object name. I create my S3 client, and then I am calling the S3 client with the bucket name and the object name, and then I'm trying to read the body. If the body exists, I'm returning the body. If it's not, then I'm returning an exception. And if this try block doesn't work at all, and say maybe my bucket name exists, but my object name doesn't exist, then I'm just returning another exception saying that one of them does not exist or something else is wrong. So now I'll demo the code and we can walk through the print statements to make sure that makes sense. So first, I have a print statement here saying get bucket object name, and you can see that the bucket is called cof cml pcde tne, and then the key name or the file name for it, the subfolder is tsysdraft5 response, and the name of the file is this, and it's the .dat file. Then right here, I'm printing out the info for the file. And as you can see, it looks like that mainframe file that I demoed earlier. A quick overview of like the length of the code, it's about 100 lines. But as you can see, a lot of these functions that I use can seem repetitive or unnecessarily strict, as in I check whether it exists at every step, I check what's wrong with it, or I check the types. And while that may seem monotonous and repetitive and unnecessary, it can be of use because anyone could take any one of these functions and reuse them in their program without having to make any modifications, because all of these functions are idempotent, independent, and they're super easy to test. So now I'm going to go through the same code in Scala, and that is this. So before I run it, this was actually my first Scala project. So if you see anything that doesn't look like it's written correctly, I apologize for that. But they basically do the same thing. I have an example of a JSON trigger right here that I just pass in as a value. I have one function that gets the element when I give a string and a JSON object to it. So it basically, what it means is if I give it a JSON object and I give it something like name, it should be able to extract the value or the child element of that name, and it would just give it back to me. That's what this function does. So then I have a try catch block where I pass in the string name and the string key to get the bucket name and the file name. Scala has auto detecting of types to some degree. So when I was writing this code, it assumed that bucket name was a list and file name was a list. So I set them both up to mirror the types that they are. And then I create an S3 client, and then I am calling the object or trying to get the object with the first item in the name in the bucket name list and the first item in the file name list. Then I'm getting the object back. And once I get the object, I am reading each line in the file, and I create an empty string of a array string here. And while the number of lines is not null, I am appending to this object that I created each line, and then I'm just printing it all out together. So hopefully this works as expected. If not, I also have it an example of how it ran above. It might be a little slow because my computer's really hot right now. Awesome. Okay, so if I scroll back up a little bit before this repetitive message, you'll see it says running hello world, trying to get S3. Then after this message, it'll say client created, which means we were able to create our S3 client, object retrieved, and then it prints out the array buffer, which looks very similar to what we saw in Python as well. So now I'm gonna stop sharing and then I'll start presenting again. Awesome. Okay. So now I'm going to compare and contrast the Scala code and the Python code. So the key differences are that because of how the Scala code is, I'm sure you've noticed it was less verbose, it was more concise, it was smaller visibly than the Python code. I don't actually have to check for side effects in the Scala code, which is really neat because like we saw earlier, the compiler doesn't work if you are trying to reassign values to types, and there's strict type checking. So when you specify a function in Scala and you specify the type of the input and the output, if either one of them don't match, your compiler will catch it and it will error out, which is awesome. And in the Python code, you could tell that I was unpackaging and repackaging with just right and left. And those are all a part of the library that I'm using to implement FP in Python. So it's a library specific thing, but in Scala, it kind of happens by default because it's so FP friendly. So you don't actually need to do that. And like I mentioned earlier, it's obviously shorter code, but the takeaways for this for me was that I felt like Python is more forgiving because I am more familiar with Python than I am with Scala. And Scala is very strictly typed, so it has a much steeper learning curve, which it's hard if you're new to FP and if you're new to Scala to put both of them together and do it in one go. So I would recommend that if you're new to coding or functional programming, I would start with Python because it's a very person-friendly language. It's very easy to read. And if once you nail down the concepts of FP and properly understand how to tell apart FP code and non-FP code, you can write it in any language. The language shouldn't matter as long as the concepts are clear to you. So if you're new to coding or new to functional programming and just want to get your feet wet, I would definitely start with Python. And if you're more experienced with Java or any other strictly typed languages, I think it would be really cool if you took Scala as a challenge and tried to write some functional programming code in it. And honestly, if you have experience with strictly typed languages and FP, I think Scala should really be a breeze to write good code in. So with that, I have some blogs here that I quote that I took sources from within this presentation. They're very good first reads to get to know more about functional programming. I just want to say thank you to Jesse, who is one of my mentors at Capital One, for helping me put this presentation together and teaching me the bare bones and concepts of functional programming. And lastly, I just want to do a quick plug-in for Capital One. If you'd like to hear more about any of our stories, how we work with our customers, or what we do in tech, be sure to click on this link in here. I will be posting a link, hopefully, in the video to a link to the slides. And honestly, we're always welcoming more people to come work here, and we have a great work-life balance, and a healthy environment. So if you're interested in applying, please go check out Capital One Careers. And hit me up on LinkedIn if you're interested in what I do or anything that you want to ask me that references to my presentation. That's all for today. Thank you.